Imagine a mountain not of solid rock but of liquid fire. It roars with a voice that shakes the ground. Rivers of molten rock flow down its sides, glowing with an infernal heat. This is the power of a volcano, a spectacle both terrifying and awe-inspiring. Volcanoes are windows into the heart of our planet, revealing the immense forces at work beneath our feet, born from the depths of the earth where temperatures are hot enough to melt rock. This molten rock, called magma, rises towards the surface. It erupts through cracks and weaknesses in the Earth's crust, creating the fiery mountains we know as volcanoes. The process is a dance of creation and destruction, shaping the landscape and reminding us of the raw power of nature. This essay will explore the fascinating process of volcano formation. We will delve into the Earth's structure, the movement of tectonic plates, and the different types of volcanoes. We will witness the fury of eruptions and understand the profound impact volcanoes have on our planet and its inhabitants. Prepare yourself for a journey into the heart of a volcano, where fire and earth collide in a breathtaking display of nature's might. To understand volcanoes, we must first understand the Earth's structure. Imagine the Earth as a giant layered cake. The outermost layer, the one we live on, is called the crust. It's thin and brittle, like the shell of an egg. Beneath the crust lies the mantle, a thick layer of hot, dense rock. The mantle is not solid, but flows slowly over time, like a very thick liquid. At the Earth's center lies the core. It is divided into two parts: the outer core, which is liquid iron and nickel, and the inner core, which is solid. The core is incredibly hot, with temperatures reaching over 9,000 degrees Fahrenheit. The heat from the core drives the movement of the mantle, which in turn influences the Earth's crust. The Earth's layers are not static. The heat from the core creates convection currents in the mantle. Hot material rises, cools, and then sinks back down, creating a continuous cycle of movement. This movement is crucial in the formation of volcanoes. The Earth's crust is not a single solid piece. It is broken into several large pieces like a giant jigsaw puzzle. These pieces are called tectonic plates. They float on the semi-fluid mantle, moving slowly over millions of years. The movement of these plates is the driving force behind many of Earth's most dramatic geological events, including earthquakes and volcanic eruptions. There are three main types of plate boundaries: divergent, convergent, and transform. At divergent boundaries, plates move apart, creating new crust. At convergent boundaries, plates collide, causing one plate to slide under the other, a process called subduction. Transform boundaries occur where plates slide past each other horizontally. Volcanoes are most commonly found at convergent and divergent plate boundaries. At convergent boundaries, the subducting plate melts as it sinks into the mantle, creating magma that rises to the surface. At divergent boundaries, the separation of plates allows magma to rise from the mantle, creating new volcanic landforms. Imagine two tectonic plates colliding. One plate, heavier and denser, forces its way under the lighter plate. This process, called subduction, creates intense heat and pressure. The subducting plate begins to melt, forming magma. This magma, being less dense than the surrounding rock, rises towards the surface. The rising magma follows cracks and weaknesses in the Earth's crust. Over time, the accumulating magma creates a chamber beneath the surface. Pressure builds within this chamber until the magma bursts forth in a volcanic eruption. The erupting magma, now called lava, solidifies as it cools, building up the cone-shaped structure we recognize as a volcano. Volcanoes can also form at divergent plate boundaries. As plates move apart, magma from the mantle rises to fill the gap. This magma erupts at the surface, creating new crust and forming volcanic mountain ranges along the spreading center. In this section, we explore the types of volcanoes, or as I like to call them, shapes of fire. Volcanoes are not all created equal. They come in different shapes and sizes, reflecting the nature of their eruptions and the composition of their magma. The three main types of volcanoes are shield volcanoes, stratovolcanoes, and cinder cones. Shield volcanoes are broad, gently sloping mountains formed by effusive eruptions of fluid lava. These eruptions are relatively calm, with lava flowing out like rivers. Mauna Loa in Hawaii, the largest volcano on Earth, is a classic example of a shield volcano. Stratovolcanoes, also known as composite volcanoes, are steep-sided, conical mountains built up by layers of lava and ash. Their eruptions are typically explosive, spewing ash, gas, and viscous lava high into the atmosphere. Mount Fuji in Japan and Mount Vesuvius in Italy are iconic stratovolcanoes. Cinder cones are the smallest and simplest type of volcano. They are built from loose fragments of solidified lava called cinders, ejected during explosive eruptions. Cinder cones have a distinctive cone shape with a crater at the summit. Paricutin in Mexico, a volcano that grew from a cornfield in 1943, is a well-known example of a cinder cone. Eruptions, nature's fireworks. Volcanic eruptions are nature's most spectacular fireworks display. They are powerful reminders of the immense energy stored within the Earth. Eruptions can be effusive, with lava flowing gently from vents, or explosive, with violent explosions that hurl ash and rock high into the atmosphere. The explosiveness of an eruption depends on the viscosity of the magma. Viscous magma, rich in silica, traps gas bubbles, leading to a buildup of pressure. When the pressure exceeds the strength of the surrounding rock, a powerful explosion occurs. Fluid magma, low in silica, allows gas bubbles to escape easily, resulting in less explosive eruptions. Volcanic eruptions can have a profound impact on the environment. Ash clouds can block sunlight, causing temporary cooling. Lava flows can incinerate everything in their path, reshaping the landscape. Volcanic gases can contribute to air pollution and acid rain. Despite their destructive potential, volcanic eruptions are also a source of life, enriching soils and creating new landforms. Volcanic impact, shaping the landscape. Volcanoes are master sculptors of the Earth's surface. Over millions of years, volcanic activity has built islands, created mountain ranges, and shaped continents. The Hawaiian Islands, for example, are a chain of shield volcanoes built by eruptions on the Pacific Ocean floor. Volcanic eruptions can create new landforms in an instant. Lava flows solidify into rock, forming vast lava fields or dramatic coastal cliffs. Ash deposits can blanket the landscape, creating fertile soils that support lush vegetation. Volcanic craters, formed by the collapse of the volcano's summit, can become lakes or host unique ecosystems. Volcanoes also play a role in the Earth's climate. Large eruptions can inject massive amounts of ash and gas into the atmosphere, blocking sunlight and causing global cooling. Volcanic gases such as carbon dioxide can contribute to the greenhouse effect, influencing long-term climate patterns. Volcanoes are a powerful reminder that the Earth is a dynamic system, constantly evolving and changing. Impact on humans, a blessing and a curse. Volcanoes have a complex relationship with human societies. They are both a source of life and a force of destruction. Volcanic soils are incredibly fertile, supporting agriculture and providing sustenance for communities. Geothermal energy, harnessed from the Earth's internal heat, offers a renewable source of power. However, volcanic eruptions can pose significant risks to human populations. Lava flows, ashfall, and volcanic gases can destroy homes, infrastructure, and crops. Volcanic mudflows, known as lahars, can bury entire towns in their path. The eruption of Mount Vesuvius in 79 AD famously buried the Roman city of Pompeii in ash. Today, scientists monitor volcanoes closely, using instruments to detect signs of unrest. Early warning systems can alert communities to impending eruptions, allowing for timely evacuations and reducing the risk of casualties. Understanding volcanoes is crucial for mitigating their risks and harnessing their benefits. Conclusion: the dual nature of volcanoes. Volcanoes are a testament to the raw power of nature. They are born from the depths of the earth, where fire and molten rock converge. They shape the landscape, influence the climate, and impact human societies in profound ways. Volcanoes are a reminder that we live on a dynamic planet, constantly changing and evolving. While volcanoes can pose significant risks, they also offer benefits. Their fertile soils support agriculture, and their geothermal energy provides a renewable source of power. By understanding volcanoes, we can learn to mitigate their risks and harness their benefits. Volcanoes are a window into the heart of our planet, revealing the immense forces at work beneath our feet. They are a source of both wonder and awe, reminding us of the power and beauty of the natural world. As we continue to explore and study volcanoes, we gain a deeper understanding of our planet and our place within its dynamic system.